Hello everyone. What we'd like to do in this video is take a look at some simple transformations of tangent, cotangent, cosecant, and secant. Okay, let's do a couple examples. So let's first try to graph. How about y equals negative tangent of 2x. Okay, go ahead and pause the video and give this one a shot on your own. Okay, let's do it. So the first thing I should think about is, what is the period of this function here? Well, normally the period of tangent is normally pi, but now I'm multiplying the input by x. You should think that actually the period should be shorter for this function because it takes me a lesser x value to get to. So if I plug in pi, that would usually bring me to a tangent of 0, but since I'm multiplying by 2x, I only have to plug in pi over 2 to get to that same output. So the period should be shorter. Well, what will be the period? Well, the way I think about it is, well, I want to know when the inside of tangent is between 0 and pi. Well, if I divide everything by 2, I'm going to have that my x value will be between 0 and pi over 2. So for tangent and cotangent, I guess for the sines and cosines we did 2 pi over that omega value, or k value as the book uses. For tangent, it's going to be pi over omega, or pi over that k value, which the k book likes to use k. Okay, so I'll have that the period, let's note that the period will be pi over 2. Okay. So pi over 2, so let's sketch that. So on the normal unit circle, normally when I was graphing sine and cosine, I was thinking about the values on these kind of like this spot on these, what I call the 4 corners. I get this 5 spots because I'm counting this one as 0 and 2 pi. And that's because the period was 2 pi. Now the period for normally tangent is pi, so I only have to think about hitting the 3 spots. So for tangent, normally what you would say is, oh, you go over to pi, and then you want to hit those spots, so boom, boom, you would go halfway in between. Now that's if I was graphing tangent, it would go x-intercept, asymptote, x-intercept, and I'd be able to graph tangent, or at least one period of tangent. Okay, but now my period is shorter. So now, since my period is pi over 2, I'm going to go pi over 2. Now I'm going to cut that in half to get pi over 4. Then I'm going to have these 3 spots to look at. Now tangent first starts out at an x-intercept, so tangent starts out at 0, then it has undefined, then it's 0 again. So it's going to go x-intercept, asymptote, x-intercept. And we could continue that over here. Negative pi over 4 and negative pi over 2. X-intercept, asymptote, x-intercept. Okay, normally tangent will be approaching upward, but notice this negative out front, I'm reflecting it over the x-axis, so it's not going to go up like this, it's going to go down. So here's our graph. Here's the graph of negative tangent of 2x. Okay, let's do a different example. Okay, let's try to graph. Let's try as our next example. How about y is equal to 3 times the cosecant of 4x. Go ahead and pause the video and give this one a shot before we do it together. Okay, let's do it. The first thing I'm going to look at here is I'm going to look for the period. Now the period of sine and cosine is 2 pi, so the period of secant and cosecant will also be 2 pi. So we'll have that the period will be 2 pi divided by 4, so that's going to be pi over 2. Okay, so let's sketch this. So pi over 2. Here's pi over 2. Okay, we'll cut that in half. We'll be at pi over 4. Cut that in half again. We'll be at what? Pi over 8. So 1 pi over 8, 2 pi over 8, 3 pi's over 8. Okay. And what I'm going to do here is I'm going to graph sine first. The way I'm going to think about this is I'm going to think about this as 3 times 1 over the sine of 4x. That's how I like to think about it. So let's graph sine. So sine. So here's 1. Let's do it down a little bit lower. So here's 1 and here's -1. Let's do this in red. Okay. So sine would normally look like this. Right here. Okay. This is what sine normally looks like. Now what I want to do is I want to graph this. I've drawn sine of 4x. I want to reciprocate this, so I want to do 1 over. So I at least know where the asymptotes will be. The asymptote will be here, and here, and here. Okay. Now normally if I were to draw, if the 3 wasn't out front, I would connect a U like this. But I'm multiplying it by 3, so the output won't be 1. I'll have to multiply it by 3. The output will be 3, so 2 and 3. This cosecant function is being stretched by a factor of 3. So what I'm going to do is I'm not going to mark here. I'm going to mark at 3, and then I'm going to go upward. -2, -3. So I'll be down here at -3. Sorry, I don't have a whole lot of room. But here, what we have in black is 1 period of 3 cosecant of 4x. Okay, just paying attention to the black and not the red. The red is just for reference to help me piece this graph together. Okay, let's do another one. Okay, let's try and graph. How about y is equal to, how about a negative, let's do a negative 2 secant of pi x. Okay, go ahead and pause the video and give this one a shot. Okay, let's do it. Let's first figure out the period, or, I mean, the way I'm going to think about this graph is I'm going to think about this as -2, secant is 1 over cosine, so 1 over cosine of pi x. So I'm going to think about the graph of cosine of pi x. Let's take a note on its period. So the period here will be 2 pi divided by pi, so the period is 2. The period is 2. The period is 2. So let's do it. Okay, so let's mark 2. Cut that in half. We're at 1. Here we'll be at 1/2, 1/2, 1/2, 2/2, 3/2. Okay, and we would normally mark here at 1 and -1. So if I'm graphing cosine of pi x, will look like this. Okay. So since I'm graphing secant, I know I know wherever the x-intercepts of cosine will be the vertical asymptotes of secant. So I'll have a vertical asymptote here, and I'll have a vertical asymptote here. Okay, so if I was graphing just secant of pi x, I would start at 1 and I would go up to my asymptotes. But what's happening here is I'm actually vertically stretching my function by a factor of 2, and I'm reflecting it over the x-axis. So if I put a 2 here and a -2 here, if the negative wasn't there, you'd start here and go up, but it's negative, so I have to start here and go down. And I would start here, go up, and then I would start here and go down. So what I've sketched here in black is one period of -2 secant of pi x. Okay, let me move the camera down just a little bit. Okay. Awesome. Let's go ahead and do one more. Okay, let's do y is equal to, how about we just do cotangent. Let's do cotangent of 4x. Go ahead and give this one a shot. Okay, let's do it. So I have cotangent. Let's first think about the period. So remember, tangent and cotangent have a period of pi. So here, if I want to know the period of cotangent of 4x, that's going to be pi divided by 4. So here's our period. Okay, so let's sketch that. Okay, so now I'm at pi over 4. Now I only need to cut this one in half. So I will be now at pi over 8. And here I'll be at 0. Okay, now I just got to think where the x and y intercepts are. Okay, so remember, if I'm thinking about tangent, let's see, tangent starts at an x-intercept, then a vertical asymptote. So x-intercept, vertical asymptote. They're opposite for cotangent. So cotangent will start with a vertical asymptote, then an x-intercept, then a vertical asymptote, and then an x-intercept, and so on and so forth. Okay? Well, if you think about this, is kind of like the first quadrant, except since my period is different, the quadrant has shrunk. So this would kind of be like the quadrant of our unit circle that would have a period of pi over 4. So this is kind of like our first quadrant. Well, in the first quadrant, cotangent is positive, so it's going to be positive in here. So it'll be positive, 0, and in the second quadrant, cotangent is negative. So we'll have this here. And here we have it. Here's a graph of one period of cotangent of 4x. I hope you'd enjoyed this video. And the next one, the next section, what we're going to start talking about are the inverse trig functions. We'll see you there. Take care.